Welcome to 3.4. We're going to be solving systems of three linear equations in three variables. So when I say three variables, I mean x, y, and z, and the coefficients of x, y, and z cannot be zero. So a system of three linear equations is what I have written above. So most of your examples will look like this one. And the solution of this type of system will be an ordered triple. So it will have x, comma y, comma z, and this point satisfies each equation in the system. So if I graphed just this first equation, it wouldn't be a line, it would actually be a plane. And then if I graphed all three, we would have three planes. And you can kind of tell from this picture that I uploaded, it comes straight out of your book. It's on page 178. But you kind of have to tilt your head sideways to read it. It got messed up when I uploaded it into this app. So looking at this one, it says exactly one solution, and that's where all three planes intersect at one point. Hopefully you can see that little black dot in the middle where they all three intersect. And this one over here says infinitely many solutions, because when those three planes intersect, they actually form a line, and if you squint your eyes you can see that black line there at their intersection. And these last three are examples of no solution. So in the first one the planes intersect, but all three of them don't intersect at one point. You can see that two of them at one time intersect, and in the middle example, again, two of them at one time intersect, but not all three of them do. And in the last example, none of the planes intersect. These are all three examples of no solution. So the key concept for solving these types of systems is to eliminate one of the variables in two of the equations. That way we'll have two variables in two equations, and we know how to do that from section 3.2. So that ties us into the second step, is solving for both of those variables and then substituting those values in to one of the original equations and solving for the last variable. Alright, let's see just how that will work. So this is my system. 4x plus 2y plus 3z equals 1. That 1 should be over here. Again, like I said, it got messed up. And 2x minus 3y plus 5z equals negative 14, and 6x minus y plus 4z equals negative 1. So step 1 says we need to get it into two variables. So I am going to look at two of the equations at a time. So I'm looking at the first equation, and I'm looking at the third equation, and I'm going to multiply the third equation by 2 because I'm trying to cancel out my y variable. So it's rewritten down here. After I distributed the 2, I got 12x minus 2y plus 8z equal to negative 2. So now I'm ready to add, and I get 16x, my y values eliminated, plus 11z equals negative 1. Okay, save this equation, we're going to need it. So I rewrote the original three equations, and I also brought over the 16x plus 11z equals negative 1 equation that we just found. So we have one equation in two variables. Now we need to get another equation in two variables. And we want the variables to be x and z, because that's what the first equation that we found was in. We eliminated the y, so we need to eliminate the y in another equation. So now looking at my originals, I'm going to use the second equation and the third equation, and I'm going to eliminate my y. So I need to multiply the third equation by 3, and when I do that, I will get negative 18x plus 3y minus 12z equal to 3. So now I'm ready to add these equations. So 2x plus negative 18x is negative 16x. My negative 3y and my 3y cancel out. And 5z minus 12z is negative 7z. And negative 14 plus 3 is negative 11. Okay, now I have another equation in two variables. So step 1 is complete. Now step 2 says we need to solve the system for each of the variables. So lining them up, I can see that my x coefficients are the same and they only differ in their sign. So I can just go ahead and add right off the bat. Usually in some cases you might have to multiply by a constant. Do you remember that from 3.2? But now we're just going to add, so our x's cancel, and 11z minus 7z is 4z. Negative 1 plus a negative 11 is negative 12. And if I divide by 4 on both sides, I'll get z equals negative 3. So now that I found my z, I'm going to plug it in to one of my new equations and find x. I'm going to plug it into my first new equation, so 16x plus 11 times negative 3 equals negative 1. So solving for x, x equals 2. So now that I have an x value and a z value, I want to plug those into one of the original equations. And I wrote those at the top. So I plug it in for, let's say, the third equation. So I'll have 6x minus y plus 4z equals to negative 1. Substituting those values in, I get y equals 1. So the last important step would be to check our answer, which I am not going to do. However, it is important and it should be done to ensure that you did the problem correctly. So now that we found our values, we need to write our answer as an ordered triple. So x, y, z would be 2, 1, negative 3. Now I would like for you to try this one on your own, but don't worry if you get stuck. I'm going to walk you through it step by step. But please just try it, so go ahead and pause. Okay, hopefully you were able to come up with an answer. Now let's see if it's correct. So first step is to get two equations in two variables. So I need to decide which variable I want to eliminate. Really, we can do any of the variables, but I'm going to pick y. So looking at equation 1 and equation 2, looks like I need to multiply the first equation by 2 so that the coefficients on the y value differs only by sign. So 2 times 3x plus y minus 2z equals 10. And distribute to every single term, and I get 6x plus 2y minus 4z equals 20. And I'm just going to rewrite equation 2 underneath it so it'll be easier to see when I add what's all going on, which is the next step. So adding 6x plus 6x is 12x. My y values cancel. Negative 4z plus z is negative 3z. And 20 plus a negative 2 is 18. Okay, so I'm going to keep this equation because it's in two variables. And now I need to eliminate the y in another equation. So I'm going to look at the second equation and the third equation. and I want to eliminate y again, so I keep the same variables. So what do I need to multiply the middle equation by so that the coefficient of y only differs in sign? Well, it looks like if I multiplied by 2, that would get me what I need. So I'm going to distribute a 2 to every term, and I get 12x minus 4y plus 2z equals negative 4. And I'm just going to drop down the third equation because I haven't changed it yet. And I'm going to add. So when I add, I'll get 13x, y's cancel just how I wanted, plus 5z, 3. This is great. Now we have two equations in two variables, and we can use our skills from section 3.2 to solve for these variables. So to solve, it looks like I need to multiply both equations, the top one and the bottom one. The top I'll multiply by 5, and the bottom one I'll multiply by 3, because I'm trying to eliminate my z variable. I picked z because 3 and 5 were smaller numbers than 12 and 13. You could have also eliminated the x value, but when I distribute, make sure we're going to every term, and I'll get 60x minus 15z equals 90, and I'm distributing the 3 to every term, and I'll get 39x plus 15z equals 9. And when you add, you're going to get 99x, my z's eliminate, equals 99, divide by 99, and I get x equals 1. Okay, I have my x value. I'm going to plug it in to one of these new equations up here. You can choose either one. I'm going to choose the top one. So 12 times x, which we said was 1, minus 3z equals 18. Subtract 12 from both sides. I get negative 3z equals 6. Divide by negative 3. I get z equals negative 2. And we have a z and an x, so we need to plug both of those into an original equation. So here's the third original equation. It was x plus 4y plus 3z equals 7. So if x is 1, I get 1 plus 4y plus 3 times negative 2 equal to 7. And I get 1 minus 6, which is negative 5. Adding 5 to both sides and dividing by 4, we'll get y equals 3. So we have all three values for x, y, and z. You would want to check these into an original equation, but make sure you're writing your answer as an ordered pair, 1, 3, negative 2. Okay, looking at this one really quickly, using the elimination method, so I would want to multiply the first equation by negative 4 if I want to eliminate my x value. So I'd get negative 4x minus 4y minus 4z equals negative 12. And I'm going to write the second equation right beneath it. And And if I added these two together, well, my x's cancel out, and so do my y's, and so do my z's. So I'd get 0 equal to -5. And since this is a false equation, we have no solution, as you can see here. So you need to try this one on your own. I'm not going to work out the solution. I'll just give you the answer after you've paused and you've worked it out so you can check if you did it right. If you did it incorrectly, go back and try to find your error. If you can't see where you went wrong, ask a question in class tomorrow. So pause the video. Welcome back. Hopefully you got the ordered triple, -3, 4, 1. Okay, so looking at this system, I see that my z's have the same coefficient and they differ by sign. So I can add those first equation and the second equation without multiplying by a constant. So I'm doing that down here. And when I do that, I'm going to get 2x plus 2y. My z's cancel. And 4 plus 4 is 8. So that's one equation in two variables. Now we need another equation, two variables. So looking at the second equation and the third equation, my z's again have the same coefficient and they differ by sign. So I can add them, and I'm going to get 4x plus 4y, z's eliminated, and 4 plus 12 is 16. So there's my other equation in two variables, and here they both are written again, and my coefficient and my x values differ by sign, so when I add them, my x's will cancel, oh, and my y's will cancel. So I'm going to get, oh, and my 16's cancel, so I'll have 0 on both sides of the equal sign. This is the identity, and so the system has infinitely many solutions. Here's one I want you to try on your own, so pause the video and good luck. Okay, so hopefully you got the answer, no solution. This is also one I want you to try on your own, so pause the video and good luck again. Okay, hopefully you got infinitely many solutions. So hopefully that all went okay for you. If it didn't, please ask questions tomorrow and I'll be happy to answer them.